Recently, I purchased this U7-Pro-Max. I got it for two reasons. First, Wi-Fi 7 support. Second, the built-in spectrum analyzer. Just for comparison, here I have a U6 Enterprise and a U6 Pro. If you compare these two Pro versions, the U6 Pro is slightly smaller, thinner, and lighter. And the U6 Enterprise is much larger and heavier. Let me try Wi-Fi 7 first. So in the diagram, you can see I connect the U7-Pro-Max access point with the PoE switch using a 2.5 gigabit Ethernet cable. I have a Wi-Fi client using the Intel BE200 card. Let me try the 6 GHz Wi-Fi band with 320 MHz channel width. In UniFi network controller, go to Wi-Fi. I created a dedicated SSID, only chose the 6 GHz Wi-Fi band. That's it. Then in the U7-Pro-Max device itself, under settings for 6 GHz, I chose the 320 channel width. Okay, this is the setting in the UniFi network controller. In the Windows 11 client, I already connected to Wi-Fi. Under the Wi-Fi properties, you can see, yes, it is using Wi-Fi 7.11be. This is the Wi-Fi card information. It is 6 GHz. However, for link speed, it's just miserable 1.5 gigabit. Apparently much worse than the advertised maximum speed, right? However, if you check the Wi-Fi client information from UniFi side, you can see the link speed is here. Much better than what's shown in Windows. So my understanding is either the Windows 11 Wi-Fi information for Wi-Fi 7 is buggy, or it just doesn't refresh frequently enough so that it doesn't give you the most current link speed. For these two, I trust the UniFi more. To understand more about the TX and the RX rate, I'm showing you the MCS index table for Wi-Fi 7. Because I only have one Wi-Fi 7 client, I'm not able to run Wireshark in order to capture the Wi-Fi frames. Then I can tell exactly what's the detailed technical information in the connection, right? I have to rely on the MCS index table and what's shown in the UniFi network controller to tell what's the exact MCS index is using. For example, for the RX rate here is 5.7, right? And I know this Wi-Fi client has two spatial streams or two antennas, if you will. I only focus on this column, which has value 2. And then the maximum speed is here, 5.76, exactly as what we got for RX rate, right? You can tell for this rate, the MCS index is 13. You can tell more information about the GI. And then for TX rate, it's 3.84. 3.84 is showing here, so it has MCS index 9. So if I use a Mac OS, I can easily tell the MCS index, but for Windows, I'm not aware of any built-in way to tell the detailed information. Basically, it's a guesswork. Fortunately, I don't have any duplicate here, so I can easily match the rate exactly. Okay, but as you know, this is just the theoretical rate on paper. So then let me do a real-world speed testing. Here in the Linux server, as you can see in the diagram, it also connects to the same switch with 2.5 gigabit connection. Let me run iPerf3 in server mode. Then in the Windows side, let me run iPerf3 in client mode. The B parameter means I want to use the Wi-Fi interface. Let me run it. For uploading, I can achieve a little bit more than 2 gigabit. And then let me try downloading. Yeah, downloading is worse, just 1.6 gigabits. Okay, it is significantly slower than the theoretical speed, right? Because it's Wi-Fi. And I guess it is also related to the quality of the Wi-Fi card I use. because I'm using a super cheap card. It just cost me $10. Wi-Fi 7 also extends the maximum channel width for 5 GHz to 240 MHz. So let me try this extreme wide channel width for 5G as well. Go to SSID, disable this 6 GHz one, then enable the 5 GHz SSID. Then enter device for this U7-Pro-Max. Go to settings for 5 GHz. Make sure I select the channel width to 40. Yeah, that's it. But after connecting to the new SSID from the Windows client, I can see the protocol is only Wi-Fi 6. And in the UniFi network controller for client information, I can see yes, it's Wi-Fi 6. And the channel width is only 160 instead of the 240 I wanted to be. If I go back, check the U7-Pro-Max under the insights, I can see for 5G, it supports all the Wi-Fi protocols. It is using the 240 channel width. So no matter how I adjust the positions of the access points and the client, I cannot achieve 240 MHz channel width for 5 GHz. I don't know whether it's because the problem of the Wi-Fi card or simply due to my 5 GHz Wi-Fi environment is not good enough to enable the 240 MHz channel width. Anyway, I cannot achieve it in my environment. Okay, but of course, the theoretical speed is good enough. It's more than 2 gigabits. Okay, move on. Now let me try spectrum analyzer. In fact, it is the #1 reason for me to purchase this access point, because I want to try all the 3 Wi-Fi bands, 6G, 5G, and 2.4 GHz. I use 3 access points, and each one provides service for 1 Wi-Fi band, and then I use 3 different Wi-Fi clients. In the right side, you can see I already connected the 3 clients to the individual access points, and I use the same Linux server to provide 3 separate IPv3 services to the 3 clients. Keep in mind the maximum speed for the Linux client is 2.5 gigabit. So the 3 clients may not reach the highest speed simply because the bandwidth limit of the server. But that's not the point, because I just want to try the spectrum analyzer in this testing. Okay, from the Windows client, run the IPv3 against the U7-Pro-Max access point. Then from Mac Mini M2, run the test against the U6 Enterprise. From the right side, Mac Mini M1 against the U6 Pro. Okay, all the 3 clients are running, and then from the Linux server side, you can see the maximum speed is already close to the upper limit, 2.5 gigabit, right? It's already saturating the bandwidth. Now is the moment of truth. Let me go to Spectrum Analyzer from UniFi Network Controller. Go to Radio. Here you can select access point, but only for U7-Pro-Max. When you click the environment button, you have the tab named as Spectrum. For other access point, you simply don't have this feature. Then let's start with the 2.4 GHz. So you can see for this Wi-Fi band, the graphics are very smooth and responsive. There are 2 charts. The upper one is called waveform. The lower one is called waterfall. So let's look into the waveform first. So the x-axis is for channels, and the color is for probability. For probability, if the number is very low, you will see green color. If the number is very high, you see the red color. Probability means the spectrum analyzer, how possible it will detect some energy at a particular point. So think about it. If a channel is very busy, it's transferring a lot of data all the time, then of course it's very easy for the analyzer to detect some energy, right? So that's why if it's busy, you will see red color. See the waterfall? Basically, it shows the history. See the color blocks? They are scrolling from the upper side to downside, right? The right side, the all red red part. Why it's so red? See what's the channel? Channel from 9 to 12. Go back to our U6 Pro. In this testing, I'm using U6 Pro to provide service for the 2.4 gigahertz Wi-Fi band, right? So then see which channel I'm using. It's channel 11. Go back to the analyzer. Channel 11 in the middle, and because we chose the 40 megahertz channel width, 1, 2, 3, 4. That's exactly why for this wide area it's showing such a dark red color, because we are doing a saturating testing, right? And for all other channels, even though I am not using it, remember this is 2.4 gigahertz, so my neighbors or my other home access points, they are also using the different channels busily, right? That's why for the whole Wi-Fi band of 2.4 gigahertz, the Wi-Fi environment is not very friendly, it's not very good. Normally that's the case for your environment as well. Basically, this is the real-time spectrum analyzer's benefit. Instead of just the traditional interference chart, for spectrum analyzer, you can see the whole Wi-Fi band in the same screen in real time. You can also see the history in the waterfall. It's very straightforward, and you can find the good and the bad channels immediately. Then let's see the 5 GHz. See 5 GHz, the bar is much narrower and we have much more channels, right? Most of the areas, they are very good. They are showing green color even in the waterfall chart. But for this wide area, why this area is so busy, let's go back to U6 Enterprise to find out what's the channel used by it. U6 Enterprise for 5 GHz, the channel width is 160 and it's using 48 channel. Then go back to the spectrum analyzer. See this area, the middle 48, the width 160 megahertz. And from the waterfall, you can see it's not super red. The main color is orange or yellow, which means it still has the potentials to be shared by other clients or even other Wi-Fi access points. Then let's check the 6 GHz. See the middle area is very bad, right? It's very red. I can tell the center channel is 90 or 100 something, right? Let's confirm the channel used by U7-Pro-Max. And you can see here in the UniFi network controller, the channel says 69. Go back to the analyzer. See why the 69 is here. It's not really in the middle of this busy area, right? To understand why, let me SSH into the U7-Pro-Max. In the right side terminal, I already SSH'd into the U7-Pro-Max. Now let me run command iwconfig just to find out what's the interface name for the access point's 6 GHz band. Scroll up. Yes, it's here. See the ESSID name? That's the one I set. Interface name is ATH6. By the way, just in this command's output, you can tell some details already. See the frequency? It's the 6 GHz and you have the bit rate, super fast, but it doesn't tell you the channel information, right? Then let me run IWDV. Remember the interface name is ATH6, right? Let's try to find it. Okay, here. It belongs to the physical number 3. Here you can find the channel 69, which is shown on the UniFi network controller for channel, right? And here we can confirm the channel width is 320 megahertz. And here, this is the value I'm trying to find out, the center channel. So even though you set all the access point automatically set the channel to 69, it doesn't mean this frequency is the center. From here, you can find the real center frequency. And let's note down this number. Remember the width is 320, right? Just by using these two numbers, we can calculate the from and to the range of the frequency. Let me do it. Then let me simply do this. 6425 subtract 160. Why 160? Remember the whole width is 320, right? Okay, I got the from. Next, let me add 160. Okay, I got the to. Now I got the from and to frequency, right? In the lower left, I have the Wikipedia article regarding the Wi-Fi frequencies. Under 6 GHz, I can find out what's the channel for the first number, 3265. 3265. Yes, it's here. It's channel 65. Let's check the analyzer. Where's 65? It's here. You can easily tell from the waterfall. Our red area starts exactly from 65, right? Then let's check the second number, 6585. 6585. Yes, it's here. The channel is 125. Where is 125? It's here. See, that's exactly where the red area ends. This confirms what we are doing in the iPerf3 testing, how it impacts the spectrum, and this is what we can see in real time from the spectrum analyzer. You can see it's a very useful tool to find out the current situation in the Wi-Fi spectrum and find out which area is busy you want to avoid and which area is green, so that you may want to set your access points channel to, right? Because of the whole Wi-Fi band display in real time, so you can also make decisions regarding what channel width you want. For example, here I'm using the 320 channel width, right? Another competing 320 channel width SSID may not have good results. Okay, I have been testing the 3 access points for more than an hour. Now let me measure the temperature. You can see the hottest one is the middle U6 Enterprise. For the left side one, the U7-Pro-Max. It's pretty warm from the upside. The U6 Enterprise is very hot in the area where I plug in the PoE cable, about 130 something. And the right side, the U6 Pro, is not hot at all. I believe partially because I only tested using the 2.4 GHz, so it's not really fully utilized. However, if I flick them over, the bottom side has completely different situation. The left side, the U7-Pro-Max, I can see the highest temperature is about 145. And the middle Enterprise is super hot. It's more than 156 Fahrenheit. And the right side U7 Pro is also close to 130 Fahrenheit. Even though the spectrum analyzer built in U7-Pro-Max is pretty good, anyway, it's an access point. It's supposed to be mounted at a fixed location. It will dramatically limit the usage of the spectrum analysis function because you can only analyze the Wi-Fi situation at a fixed point, right? As a temporary solution, I built this cumbersome setup. Here I have an electric tool battery and a inverter so that I can have a 120 volt AC output. Then I plug in the Ubiquiti's PoE Plus adapter and then connect to this Wi-Fi. So in the UniFi network controller, I set the Wi-Fi's connection mode to mesh so that it can communicate with my other access points using Wi-Fi mesh. When I use it, I will put all these things into one backpack. Then I will handheld an iPad and display the spectrum analyzer. At this moment, I put the U7-Pro-Max in the middle of the house, not too close, also not too far away from the U6 Pro and the Wi-Fi client. That's why in the right side of the spectrum, especially in the waterfall, you can see the color is mainly orange, not yellow, also not dark red, right? Which means Wi-Fi situation is okay-ish, not too bad, not too good. Now fast forward. Okay, now you can see I am moving from the middle of the house to a far corner, so that now the U7-Pro-Max is very far away from both the Wi-Fi client and the U6 Pro. That's why from the waterfall you can see the color is becoming more yellow. Okay, now I start moving to the exact location of the U6 Pro and the Wi-Fi client. You can see the waterfall is becoming red, and later it will become complete dark red. See, now it's apparent, right? Very dark red color. Okay, now you see the effect of a simple mobile spectrum analyzer's effect just by using a access point. This is the end of the video. Thanks for watching.